This presentation is actually an update on one that we did quite some time ago. It has improvements that will enable all of us to understand the topic much better. It contains information that every CERT member should know. In this presentation, we will explain the reasons why damage assessment is so important for those of us on the various CERT teams. We will go over some of the reasons why earthquakes cause so much damage to buildings. We will explain why the residents of the terraces of Los Gatos are living in one of the safest types of structures for earthquakes. And most important of all, we will tell you how to do a preliminary assessment of whether it is safe to be near a structure that has experienced an earthquake. As we begin this topic, I want to tell you that this presentation will not make you into an expert on geological aspects of earthquakes, and it won't come as any surprise that this presentation will also not make you an expert in structural engineering. Our goal here is to give you enough information to allow you to stay safe when you are doing your CERT work around buildings that have been subjected to earthquake shaking. If you haven't already guessed, we regard damage assessment as an important topic for every CERT member to understand. The main reason for this is that we do not want CERT team members to enter buildings that are unsafe. So until it has been determined that our various buildings are safe to be around, we will not deploy teams on our property. If you are activated, you should take particular note of any signs of damage that you observe as you walk to the CERT gathering place. Should you happen to see potential signs of damage, please be ready to report the details of these to the CERT leadership. Here at the terraces of Los Gatos, the main responsibility for damage assessment lies with our facilities staff. However, if these people are not available to do the assessment, or if an aftershock comes after you are already deployed, we should be ready to do our own update on the state of our facilities. So your actions just after a significant earthquake should be as follows. First, shelter in place until you are called to deploy. Second, do not deploy until you have checked your own apartment, your family, and your pets. Only then should you put out your "I'm okay" sign. Third, when you deploy, be sure to wear the required CERT equipment and carry your GO kit when you come to the Emergency Operations Center. Fourth, please know that you may need to be in CERT operation for as much as 8 hours, so be sure to come prepared for this possibility. Fifth, as you deploy, be sure to take note of your surroundings and always look for signs of unsafe conditions. In this presentation, we will give you guidelines of what to look for. Now, before we go into the specifics of building damage, there are a few things about earthquakes you should know. To start with, earthquakes come in clusters. In addition to aftershocks, there is always some chance that the earthquake we just experienced was a foreshock to something larger. Fortunately, the rate of additional earthquakes decays quite rapidly. Based on the statistics of earthquakes worldwide, here's my rule of thumb. There's about a 1 in 10 chance of experiencing additional earthquake shaking as strong or even stronger in the coming 10 days. So here's the bottom line. We need to avoid damaged structures because additional shaking increases the chance of structural failure. Not just human-made structures fail in earthquakes. The ground itself can fail and create hazard. Here at the terraces, the geologic conditions are such that we really need to concentrate only on ground cracks and fault offsets, which present tripping hazards and can damage pipelines and building foundations. Based on the 1989 Loma Prieta earthquake, it appears that Los Gatos and neighboring areas may have an above-average hazard from ground cracks and small offsets. These are just two of the many examples of extensive cracking that occurred in Los Gatos. And you can see that one is offset and one is just a simple opening crack. This map of ground cracks from the post-Loma Prieta earthquake study show a number of interesting features. The authors identified 4 zones of intense cracking. There's the Santa Clara zone, the Los Altos Campbell zone, Los Gatos zone, and Blossom Hill zones. As you can see, the terrace is sandwiched between the Los Gatos and Blossom Hill zones. And in fact, in 1989, there were a couple of ground cracks in our vicinity that were mapped. All right, now let's take a look and talk about damage. There are two kinds of damage that we'll likely encounter on our property. The first is cosmetic damage. This is damage that is inconvenient but otherwise not harmful to residents. For example, your apartment may have pictures that come off the wall or furniture that is moved about. The second type is what you should be particularly wary of because it poses a threat to the safety and well-being of our residents and staff. This is damage that has the potential to be hazardous because it can lead to injury or death of those who are unaware of the potential harm. For example, it might include structures that have collapsed, shards of glass, sources of fire, or trip hazards for those who walk along our various pathways. So you may wonder why damage happens to buildings in earthquakes. As the ground beneath the building moves, the building shakes and deforms as it tries to keep up with the motion of the ground. If the deflection is large enough, the building will undergo permanent damage and will fracture some of its key structural members. As you can see in this picture, the skewing of a building from side to side can lead to cracks at the corners of windows and doors. These cracks are often evidence of internal damage that does not show, but can lead to the eventual collapse of the structure. Although this simplified picture shows only left and right movement, in reality, the motion can be in many directions, including a twisting of the structure. Although it may feel like much more, the actual movement of a structure during an earthquake is typically no more than 1 inch for every 8 feet of height. For this reason, the third floor of a building may see more motion relative to the ground floor than the first floor. If the displacement exceeds this small amount, that is 1 inch per 8 feet, there may be fracture of beams and failure of other important structural members. The problem is that it may be difficult to know how much damage has occurred since the beams and key structural members are almost always covered by wallboard, siding, and roofing material. So we have to have ways to predict possible internal damage based on external observations. We'll discuss this later in the presentation. In reality, the amount of damage depends on a number of factors. The first is strength of shaking, which in turn depends upon the earthquake magnitude, its distance, and the rock type or soil conditions under the building. The second factor is the length of time of shaking. The larger the earthquake, the longer the duration of intense shaking, and the greater the damage. And the third is the type of construction: wood frame, brick, steel frame, reinforced concrete, and so on. So you may be wondering what type of construction we have here at the terraces. Our buildings are designed to the latest standards for earthquake resilience. Our residential buildings are wood frame construction. This leads to the question about whether wood frame construction is safe for the survival of occupants during a significant earthquake. This is from a study done in 2006 that shows fatalities from earthquakes are actually the lowest for those people residing in wood frame buildings. This study showed actual data from some significant earthquakes worldwide. The shape and material of the building is also key factors in determining earthquake resistance. Among those factors are L-shaped buildings or those with large open expanses are much more likely to see damage. Because bricks and unreinforced concrete are brittle, they are more likely to have damage in an earthquake. Because steel frame structures are ductile, they are less likely to have damage in an earthquake. Small, more rectangular buildings with plenty of internal walls are among the safest. Who would have thought that moving into a small apartment at the terraces would bring you to a safer place? Your greatest risk of injury at TLG during earthquakes comes from falling furniture and flying objects. So it's very important to have your furnishings well secured and your kitchen cabinets well latched. Also make sure there are no glass framed pictures above your head of your bed. The truth is The greatest damage in an earthquake happens when the building is shaken at the same frequency that would not naturally sway or vibrate. In this situation, the stress and displacement can actually be amplified as the shaking continues. This behavior is especially important if the structure does not have a way to absorb or dissipate the energy it is receiving from shaking. Modern construction methods provide for intelligent ways to dissipate the shaking energy. This leads to the saying that the safest buildings are not those that are the heaviest or the sturdiest, but those that are constructed in a smart and efficient ways. Given this information, it's reassuring to note that, first, wood frame structures are designed to allow occupants to survive a significant earthquake. This photo on the right shows a building that is significantly distorted and is no longer fit for habitation, but is a building that protected its occupants. In other words, this means that low-rise, wood frame buildings are designed more for occupant safety than for overall survivability of the structure itself. Most experts conclude that the safest place to be at an earthquake is inside a low-rise wood frame building. So the best thing to do during an earthquake here in Los Gatos is to shelter in place using the well-known technique, drop, cover, and hold. Now about damage assessment. There are at least two different ways to do damage assessment. The first way is what is done by professionals. It involves inspecting the key structural members that support a building. Sometimes this even requires inspectors to remove siding or wall boards to see features that would be otherwise hidden. The second way is to look for outside evidence and infer from experience that the internal damage has likely happened. This is based on observations of those who have had experience with earthquake damage at other locations and other times. It is from these experiences that we can develop guidelines to predict the likelihood of damage. It is this approach that we will use for our CERT teams as they look for potentially unsafe situations. Most damage assessment teams utilize this document, published in 2007, based on experience and observations from both the Northridge earthquake in 1994 and the Loma Prieta earthquake in 1987. It is a guide for damage assessment that has been adopted for use by TLG. Because of their expertise and experience, the document was studied carefully on our behalf by Bob Hamilton and Woody Savage. A copy of this document is in the hands of our CERT leaders and forms the basis of what follows in this presentation. The Curie publication categorizes damage level in the building in a way very similar to CERT categories of injury of humans. In most cases, a building will have a tag permanently affixed by qualified inspectors to indicate the state of damage. A green tag means there's light damage, the building is likely safe to occupy. A yellow tag means that the building has some inward signs that may point to internal damage and that may render the building unsafe for occupancy. And finally, a red tag means that the building has obvious signs of damage that render it unsafe for further occupancy. Today, we offer you 8 guidelines that you can use to do a preliminary assessment of the safety of a building. These are usually things you can observe without the need to enter the building or to place yourself in danger. The first thing you can do is look for structures or trees that are down or leaning such a way that are likely to topple at any time. I think it's interesting that the top right photo shows 1 or 2 very flimsy props that are used to shore up this leaning building. I have significant doubts about the ability of these tiny props to actually hold the building up. On the other hand, these props might provide a way to show progressive displacement as the building continues to lean with an increasing angle. Next, broken glass or debris alongside a building is a strong indication that something is very wrong with the integrity of the structure itself. Keep in mind as you walk by a building that has debris nearby that it is possible that additional pieces may fall off and injure those who walk by. So stay clear of these areas. Next, significant cracks and discontinuities inside and outside the building are often an indication of hidden damage inside that wall. These are most likely to happen at corners of windows, corners of doors, and places where flat surfaces come together. Also remember that cracks in sidewalks or driveways or other areas around the outside of a structure can often give an indication of damage that may be hiding inside or under the structure where you can't see it. If you see architectural features that were once straight, vertical, or level that are now crooked or broken, fractured or uneven, this is often a strong indication that the integrity of the structure has been compromised. So it is best to avoid these buildings. These features can be more subtle than these extreme examples in the figures. Notice that the two buildings on the left have both been red tagged to indicate they are unsafe. It seems quite likely that the other two buildings will also achieve that status as soon as inspectors do their work. A leak in water pipes tells us that the pipes have sustained enough stress to break. If this happens, it is likely that the structural members of this building have also sustained damage. Additionally, a broken gas line can lead to an explosion or fire if there are ignition sources present. Although it doesn't relate to whether a building is damaged or not, it's important for CERT members to listen for sounds of people calling for help from within buildings. Most buildings will make occasional sounds under normal conditions, but sounds that happen after an earthquake may be signs that the building is slowly undergoing deformation. So listen for sounds that are different from the occasional sounds that most buildings make. You may recall that in Florida, the building that collapsed a few weeks ago gave creaking sounds as much as 24 hours before it actually fell. Listen to this example of sounds that may be warning of an impending disaster. Your observation should not be limited by your sense of vision. Other human senses can also provide meaningful information. Your sense of smell is a good example. A smell of smoke almost always indicates that a fire is present somewhere, even if you can't see the flames. Smell of rotten eggs is an odor that PG&E puts into natural gas to warn of possible gas leaks. And where there is a gas leak, there's also the possibility of an explosion or fire. The smell of raw sewage often indicates a break in a sewer line. If the ground is moved enough to break these lines, is moved enough to break structural members of the buildings nearby. So here's what you should do if you encounter any of the 8 things we have described. First, don't try to fix things or rescue people alone. In CERT, we always do things in pairs. Second, write down the things you see with enough detail that others can find these easily. Be sure to include what and where, and take a photo with your cell phone if you think it would be useful. Finally, when you arrive at the CERT assembly point, report what you have found to the leaders at the TLG Emergency Operations Center. And finally, do your best to avoid risky situations. If you're unsure about the safety of a particular building or area on campus, it's best to avoid that location. If you're unsure about the safety of a situation, be sure to ask for advice from those who may have more experience. Remember, the goal of CERT is to do the most good for the most people in the minimum time. If you get trapped or injured, you are then unable to help others. So try to avoid becoming a rescue person who needs to be rescued. We have time for questions. Terry and I will be happy to answer these to the best of our abilities.